When the Sandbox is the story. Anthropic shipped Claude Opus 4.8 last week alongside a $65 billion Series H at a $965 billion valuation, but the more revealing publication was the engineering blog post detailing how the company actually contains its own agents across products. The model itself is an incremental upgrade. Better calibration, 4 times less likely to let flawed code pass unremarked, improved agentic judgment, and a new dynamic workflows feature that lets Claude code run hundreds of parallel subagents in a single session. Early testers call it the first model to complete every case end-to-end on super agent benchmarks, beating prior Opus models and GPT-55 at cost parity. Effort controls now let users choose how hard Claude thinks, from low, faster, cheaper to max, deep reasoning. Fast mode for Opus 4.8 is 3 times cheaper than for previous models. Pricing holds at $5/$25 per million input/output tokens. The containment post, however, is the piece worth reading carefully. Anthropic describes 3 isolation patterns: ephemeral containers for Claude.ai, an Oz-level sandbox, seatbelt on macOS, bubble wrap on Linux for Claude Code, and a full VM via Apple's virtualization framework for Claude Cowork. And then candidly catalogs where each one broke. Between mid-2025 and January 2026, 3 Claude Code vulnerabilities exploited code that executed before the user even saw the trust dialog. A malicious.claude/settings.j nhook in a cloned repo ran automatically at startup. In February 2026, an internal red team fished an Anthropic employee into pasting a prompt that exfiltrated AWS/credentials. Successfully, 24 out of 25 attempts. The model layer had nothing anomalous to catch because the user was the injection vector. A third-party disclosure then showed that Claude Cowork's egress allow list for ap.anthropic.com could be weaponized. A malicious file in a mounted workspace instructed Claude to upload other workspace files using an attacker-controlled API key, and the proxy let it through because the destination was on the allow list. The fix required a defensive man-in-the-middle proxy inside the VM that rejects any request not carrying the VM's own provisioned session token. The recurring lesson, battle-tested hypervisors held, every failure came from custom code the team built around them. Prompt injection. Still winning. OpenAI's ChatGPT for Google Sheets extension, which accumulated over 185,000 downloads in its first month, turns out to be a textbook case of the trust inversion problem. Prompt Armor demonstrated that a single indirect prompt injection, hidden in white text in an imported spreadsheet, can trigger ChatGPT to run an attacker-controlled Google app script that exfiltrates workbooks across the victim's entire account, displays a phishing overlay replacing the ChatGPT sidebar, and edits sheets with attacker-controlled content. The kicker: this works even when the user has explicitly disabled automatic edits. The malicious script crawls links between workbooks, exfiltrating 12 in the demonstration. OpenAI's response, after 3 weeks of silence following responsible disclosure, was to remove the model's ability to generate app script code entirely. That incident lands alongside PIArena, a new unified platform for prompt injection evaluation out of Penn State that systematically demonstrates how badly current defenses generalize. The researchers integrated 8 state-of-the-art defenses, both prevention-based, PIAsanitizer, Secaline++, Data Filter, Prompt Armor, and detection-based, Data Sentinel, Prompt Guard, Attention Tracker, PIGuard, and evaluated them across diverse benchmarks spanning QA, summarization, RAG, and code generation. The results are sobering. A novel strategy-based adaptive attack that iteratively rewrites injected prompts based on defense feedback achieves 99% attack success rate without any defense, and 86% against PIAsanitizer, versus 4% for static combined attacks against the same defense. Even GPT-5, deployed with a multilayered defense stack, exhibits 70% ASR. The most uncomfortable finding, when the injected task aligns with the target task, like corrupting answers in a QA pipeline, the attack reduces to disinformation, and no existing defense can handle it, because there are no malicious instructions to detect. The researchers note this aligns with OpenAI's own recent observation that the most effective real-world prompt injection attacks increasingly resemble social engineering. On the offensive side of the ledger, the CAI, Cybersecurity AI, framework from Alias Robotics continues to mature as the de facto open-source toolkit for AI-powered security testing. The framework supports over 300 AI models, includes built-in tools organized along the security kill chain, and has demonstrated a claimed 3,600x performance improvement over human pentesters in standardized CTF benchmarks. Its Alias 1 model reached rank 1 during hours 7 to 8 of the Dragos OT CTF 2025, completing 32 of 34 challenges. Real-world case studies include finding critical vulnerabilities in Unitree G1 humanoid robots, unauthorized telemetry to China-related servers, exposed RSA keys, and ecoforest heat pumps, remote access with DES encryption weaknesses. The framework includes guardrails against prompt injection of the security agents themselves and supports MCP integration, a reminder that the same protocol designed for helpful tool use is also an attack surface.
Agents break in boring ways. A studio called Firespawn ran 25 LLM agents across 8 open-weight models: Qwen 3235B, Qwen 332B, Nimatron 3 Nano 30B, Ministral 14B and 8B, Gemma 312B, and others, in a persistent text-based MMO for 10 days, logging 93,000 events with reasoning traces. The dataset, released under CC-BY-40, reveals patterns that static benchmarks cannot. Qwen 3235B independently invented arbitrage. Nobody told it to be a pacifist merchant, but it examined the JSON state, calculated risk/reward, and adopted a buy lower list high strategy, hoarding a third of all shard wealth while engaging in combat only 8% of the time. Ministral 8B and 14B held their own on long-term state awareness despite their size. One Nemotron agent died over 300 times because its directive was simply gather, with no survival cost. Dying and respawning was the optimal policy under the reward function as specified. The most universal failure was the cooldown paradox. A resource node showed node available, true while the agent's personal cooldown was still active. Every model from 8B to 235B failed identically, retrying until a single-line state clarification fixed the problem. The takeaway: much of what looks like reasoning failure may actually be ambiguous state signaling. That ambiguity problem scales poorly in multi-agent architectures. A practitioner running QWEN3.6-35B-A3B as a subagent on a single 4090 reports a specific failure pattern. The model processes tasks in thinking mode, produces structurally correct but semantically wrong output, and the orchestrator accepts it because format validation passes. With MoE, mixture of experts, architecture, certain task types hit cold experts and performance drops with no signal that it happened. The fix is validation at the boundary. Schema checks catch wrong shape, but not wrong claim. So each subagent handoff needs a task-specific verifier beyond format compliance. For those giving agents more autonomy, a developer built an LXC-based sandbox framework for codecs on headless Linux with GPU pass-through, persistent environments, and multiple parallel browser sessions. The goal being let the agent run free while limiting the damage it can do. The design uses LXC containers rather than full VMs so multiple instances can share a GPU, with Git push hooks preventing history rewrites. Meanwhile, SDAR, self-distilled agentic reinforcement learning, from Zhejiang University tackles agent training itself, using self-distillation to improve agentic RL on environments like ALF World, WebShop, and SearchCA, achieving substantial improvements over standard GRPO baselines by having the model learn from its own successful trajectories. Your hardware is smarter than you think. Prismel's Bonsai Image 4B is the first image generation model in its parameter class to run on an iPhone. Built from Flux.2 Klein 4B, it keeps the architecture intact but moves transformer weights to binary, -1, +1, 1.125 effective bits, or ternary, -1, 0, +1, 1.71 effective bits form. The 1-bit variant compresses the diffusion transformer from 7.75 GB to 0.94 GB, an 8.3x reduction. The ternary variant lands at 1.21 GB, retaining 95% of Flux.2 Klein 4B accuracy across Geneval, HPS v3, and DPG bench. On iPhone 17 Pro Max, Bonsai generates a 512x512 image in 9.4 seconds. On Mac M4 Pro, about 6 seconds and up to 5.6x faster than the stock full-precision MFLUX pipeline. Mean active memory during 1024x1024 generation is 1.95 GB for the binary model versus 14.39 GB for full precision. Open weights under Apache license. Not everyone needs new hardware. A developer dusted off a 2013 trash can Mac Pro, originally 10,000 pounds, with dual D700 GPUs, Southern Islands architecture, and discovered that new Vulkan driver support in recent Linux kernels brought its 12 GB of VRAM back to life for llama.c PP inference. Benchmarks: Qwen 3.59BQ4 at 11T/s, Qwen 2.5 Coder Q4 at 22T/s, both at 70K context. Not fast, but usable for planning tasks where you set it and forget it. On the opposite end of the hardware spectrum, a heterogeneous GPU optimization for Llama reverses the default layer-splitting algorithm, so the strongest GPU fills first instead of last. The single most impactful change: greedy fit iteration direction. Combined with compute power weighting, SM count, clock megahertz, and forced output layer placement on the fastest card. An RTX 5090 plus RTX 3090 combo now outperforms the 5090 alone, where previously the 5090 idled while the 3090 bottlenecked. Intel's Arrow Lake NPU, often dismissed as a marketing gimmick for LLM workloads, turns out to be genuinely useful for automatic speech recognition. Running ONNX compiled Whisper on the 13 TOPS NPU via OpenVINO delivers 4.8. 6.1x faster transcription than INT8 CPU inference, but the energy numbers are the real story. 10.7. 21.6x less energy per transcription. A 60-second audio clip takes 818 ms on the NPU at 13.4 W above idle, versus 5011 ms on CPU at 47.4 W. For smart home voice commands, the NPU's instant wake-up from dormancy actually beats an RTX 3060 eGPU on short utterances. MOS TTSV1. .5 rounds out the local audio story with improved multilingual synthesis across 31 languages, more stable voice cloning, explicit pause control via inline markers like, and a companion MOS sound effect, V2. .0 model for 48 kHz bilingual sound effects up to 30 seconds. The token bill comes due. A Brian Krebs LinkedIn post captured a WSJ report that enterprises are hitting their annual AI token budgets in 3 months, with spending doubling or tripling as providers stop subsidizing prices. Companies are scrambling to ration AI use, steer employees toward cheaper internal tools, and hone skills to improve returns. The community response was pointed. One practitioner running 3 concurrent research projects, 8 apps, and 4 harnesses reports spending $300/month total across Claude and GPT subscriptions, arguing that the cost blowouts come from handing tools to people who don't understand model tiering. Opus is not the tool to use in a business situation 99% of the time, or context hygiene. /compact and /clear. The pattern echoes the cloud migration regret cycle. Low prices drove adoption, then the bill arrived, and the switching costs were already locked in. Reuven Cohen quantified the professional end of this curve. A single developer running Claude code in swarm-style development burns roughly $2.500 day or $75.00 a month via the Anthropic Enterprise API. His argument is that the biggest cost isn't the model. It's the constant replay of context. Architecture documents, ADRs, source files, and conversation history get resent every loop iteration. His company's approach operates at the ASD and semantic level rather than treating code as raw text, routing only the pieces relevant to the current task. Combined with prompt caching, selective model escalation and retrieval, he claims multiple cost reductions while maintaining output quality. Every token you don't send is a token you don't pay for. The workflow evolution is visible in practice. A content creator describes assembling context windows manually. Telling Codex to find files by natural language description, copy them into a clean working folder, then open a new chat pointed at that folder with explicit instructions. The result, 30,000. 50,000 word document work, complex spreadsheet operations, and multi-threaded idea incubation that just works. Because Codex treats text files the same as code files in a repo. The shift from prompt engineering to collaborative task shaping, defining the shape of the work with the model before executing agentically, marks a maturity inflection. A developer reflecting on 8 years at Atlassian, where they built an Envoy control plane called Sovereign, serving 2,000 proxies across 13 AWS regions, plus an authentication sidecar in Rust, offered a counterpoint to the AI everything narrative. Building something is easy. Changing it and making sure that you can still change it over time is difficult. The maintenance burden. Onboarding cycles, code-based churn, coupled changes. Doesn't appear at the start. Whether AI-assisted vibe-coded apps can handle that long tail remains an open question. Memory, multimodal training, and the personal AI stack. Deja Vu is a local-first AI memory layer that stores context in SQLite at Deja Vu and exposes it via Python SDK, CLI, REST API, and MCP server, meaning a preference added from the terminal is immediately available in Claude Desktop or a Python agent. Same database, no sync, no account. LLM calls root through Venice's privacy-focused API. Everything else runs locally. It's the latest in a crowded field of local memory tools. But the multi-interface approach, one store, every tool, and the MCP integration give it practical stickiness. UNIMM Trainer fills a gap that more prominent projects have stepped around. A small, opinionated library for training multimodal models that combine at least 2 of text, vision, and audio. Plug a frozen encoder, Whisper, Kilipip, Siglip Dinov 2, into a language backbone, Llama, Quen, Mistral, train only the projection adapter, linear, Q-former, perceiver resampler, and get modality balance loss reporting, frozen encoder feature caching, and sensible LR ratio defaults. It doesn't try to be a foundation model release or a serving framework. Just a correct training loop that saves you from forking Blip2's 5000 line codebase. The Cognitum 1 seed pushes further into ambient intelligence, a self-contained AI computer that fuses mmWave radar, 24 GHz for 2D position tracking, 60 GHz for contactless heart rate and breathing, Wi-Fi CSI from ESP32, node arrays for through-wall presence detection, and IMU data. All processed on device with vector memory, no cloud required. The critical constraint most guides skip. Wi-Fi CSI needs a minimum of 3 nodes for basic triangulation, with 7 recommended. The review software layer produces a 128-dimensional anonymous identity fingerprint from CSI data, enabling re-identification across sessions without cameras or wearables, though it currently ships without pre-trained weights. On the Cognitive Revolution podcast, Nathan Lebenz detailed his personal AI infrastructure, a 1 GB SQLite database containing 5 years of digital history, emails, calls, podcasts, DMs, social media, with monthly and annual summarization layers plus a 500 article wiki of profiled individuals and organizations, all searchable by Claude Code on his laptop. His experimental second layer, 2 autonomous AI employees named Aid and Clay, running on a dedicated Mac Mini via Tailscale, with their own Gmail accounts, GitHub access, and restricted virtual credit cards. As a proof of concept, Aid autonomously booked a full week of podcast guests from a 25-person candidate list, managing communications without most people realizing they were interacting with an AI. Security researcher Daniel Mesler emphasized that a clear hierarchy among AI agents still beats emergent teamwork, and both agreed on always preserving raw data so systems can be rebuilt as capabilities improve. Bitter lesson engineering.